Welcome back to the video, guys. In this video, we'll be discussing the first 5 questions of activity 1.5, which is based on determinant 2. So let's get started. Here, the first question says A is a 3 cross 3 matrix, then the determinant of A is equal to determinant of A transpose. So we know this property of determinant, that the determinant of A, any matrix A, is equal to the determinant of its transpose. We can easily see this with the help of an example. So if I take A as some 3 cross 3 matrix, so I'm taking A as ABC, DEF, and GHI. So here, if I take A transpose, what it will give me? A transpose is going to be, so to take the transpose, I take the row and I write them as the columns. So ABC is my row 1, so I'll write it as my column first. ABC, now here is my column 1. Similarly, DEF is the row 2, so I'll write it as the column 2. And then GHI is the row 3, so I'll write it as my column 3. So this is my A transpose. Now let's try to take the determinant of both A and A transpose. So determinant of A is going to give me, I'm expanding along row 1. So it is A times of, just eliminate this row and this column and I'll be left with this determinant EFHI. EFHI minus B of B times of DFGI. And then plus C times of this determinant DEGH. Now I can do the same for A transpose as well. So if I do the same for A transpose, it will give me, now here I'm not expanding it along row 1, I'm deliberately expanding along column 1. So let's do that. A times of EHFI, now minus B times of this determinant. So just eliminate this row, eliminate this column, and I'll left with DGFI. DGFI plus C times of, eliminate this row, this column, and we are left with DGEH. So here we can see that the coefficients of these matrices are same, but the matrices look a bit different. So let's see what's hidden inside them. Here, if I talk about this particular matrix, it will give me EI minus HF. And if I look at this matrix, it will also give me EI minus HF. Now I can do the same for this as well. This is going to give me DI minus G times F. Similarly, D times I minus G times F. And here also I can get D times H minus E times G. And here also I'm getting D times H minus G times E. So that means both determinant of A and A transpose are equal. And we saw this with the help of an example as well. So that means the option 1 is correct. So marking it as correct. And now let's move on to the question second, where it says that A is a real 4 cross 4 matrix. Then the order of submatrix obtained by deleting the ith row and the jth column. So first, let's take any arbitrary matrix of order 4 cross 4. So here I have my AS, ABCD, EFGH. Let's take PQRS and XYZW. So if I just eliminate any of the row and any of the column, so for example, I'm taking row 2 and column 3. You can take any column and any row of your choice. So this first I deleted the row 2 and now I'm going to delete the column 3. So if I do this, this would result in this particular matrix, which is AB. Third column is deleted. So I'll get D here. Now second row is deleted. So I'm just left with PQS and XYW. So here I can see that if I eliminate one row and one column from a 4 cross 4 matrix, I get a 3 cross 3 matrix. So that means option 2 is incorrect. Whereas the option 3 is correct because the option 3 says by deleting the ith row and the jth column, I will get a 3 cross 3 matrix, not a 4 cross 4 matrix. Now, option 4 says that if A is a real 3 cross 3 matrix, then the orders of all possible square submatrices are 1 cross 1, 2 cross 2, and 3 cross 3. So, first question arises that what are submatrices? So, submatrices are the matrices obtained by deleting some row and some column. Okay. So, let's say I have a 3 cross 3 matrix. For option 4, if I have a 3 cross 3 matrix, and I am deleting one column and one row, deleting any one row and any one column. So that would result in a 2 cross 2 matrix. So a 3 cross 3 matrix can have a submatrix of order 2 cross 2. But now on the other hand, if I delete any two row and any two column, so after deleting any two rows and two columns, I will get a 1 cross 1 matrix. So a 3 cross 3 matrix can also have a submatrix of order 1 cross 1. And then what about a 3 cross 3 matrix? So we know that any matrix is a submatrix of itself. So any matrix is a submatrix of itself. And by that logic, we can say that yes, a 3 cross 3 matrix is also a submatrix of a 3 cross 3 matrix. A submatrix of itself. So thus we can say a 3 cross 3 matrix is also a submatrix of a 3 cross 3 matrix. That means option 2 is also correct. Option 4 is also correct. So this was all about question 1. Now let's move on to the question second. The question second says A is a 3 cross 3 matrix and which of the following options are correct about the determinant? So here determinant are calculated by expanding different rows or different columns. So what about option A? So in option A, we can see that there is a 3. In row 1 also we have a 3 and then there is a 2 and then there is also one more 2. So in row 1 there is 3 2 2 and column 1 also there is a 3 2 2. So is it about the row 1 or the column 1? Let's check that. So let's take the matrix itself. So if I take this matrix, yeah, and I expand it along R1, what I will get? So I will get determinant of A as 3 times of this matrix, 3 2 1 1, minus of 2 times of this matrix, 2 2 2 1, and then plus 2 times of this matrix, 2 3 2 1. So if I expand along R1, I'm getting this matrix, and here I'm getting this value, and here I can see this is my option 1. Okay, now moving on to the option second, I can see that the first uh, term is same as option 1. The last term is also same as the option first. The only difference lies in the second term over here. That is, the signs are different, and here I can see a column has been exchanged. So here 2 1 is column 2, but here 2 1 is column 1. So to go from here to here, I am just interchanging the positions of column 1 and column 2. And we have seen that if we interchange any two columns with each other, then the value of determinant gets multiplied with -1. And here we can see that when the value of determinant gets multiplied with -1, so this minus sign changes into a plus sign. So that means it is just option 1 written in a different way. So option 2 is correct as well. You can see from here as well that if we write the same thing as 3 times of 3 2 1 1 minus 2 times of just interchanging column 1 and column 2 with each other, that would give me 2, 1, 2, 2. But because I have interchanged two columns with each other, I'll also have to multiply with -1, and then it is 2 times of 2, 2, 3, 1. And this is nothing but my option 3. So option 2, sorry. So option 1 and option 2 are correct. Now moving on to the option 3. In option 3, it is -2 times of some determinant plus 3 times of something, and then again -2 times of something. So here we have seen that we have A. Now, if I expand A along row, so we have seen that if we expand along row 2, we use these symbols minus, plus, minus. Because along the row 1, we use plus, minus, plus. So it is basically plus, minus, plus, minus, plus, minus, and then plus, minus, plus again. Okay, so do that along R2. First, we will start with -2 times of 2, 2, 1, 1. 2, 2, 1, 1, and then plus 3 times of 3, 2, 2, 1, and then again -2 times of 3, 2, 2, 1. And this is nothing but our option 3. So option 3 is also correct. Okay. And about option 4, so if you multiply the expression provided in the option 3 by -1, then you will obtain option 4. So that means option 4 is minus of determinant of A, not determinant of A. So option 4 is incorrect. So this was all about question 2. Now let's move on to the next question. That is our question 3. Here it says, if all the elements of a 3 cross 3 real matrix A are same, and which of the following is are correct? So here, let's take an example. I'm saying my A is a 3 cross 3 matrix such that all the elements are same. So I'm saying that all the elements are K, 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 K. Okay. So I know this fact that if I add any multiple of a different row in some row, then the value of determinant does not change. That means if I have my Ri with me and I add some K times of some other row, Rj, then by doing this operation, the value of determinant will not change. That means if I have all the elements of same, uh, so I can easily do my R1 going to R1 minus of R2. So that would give me a row which is basically 0. K, 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 and K, K, K again. So since I have a 0 row, I will get the value of my determinant as 0. So determinant of matrix A is 0. The first option is correct. Determinant of matrix A, we have just determined the value of determinant, so it is incorrect. Now the third option says the determinant of A will be the sum of elements in a row. So we have seen that sum of elements in row is 3k, but the determinant is not 3k, it's 0. So option 3 is incorrect as well. Now moving on to the fourth option that says determinant of a matrix A plus A transpose is 0, where A denotes the transpose of A. Now, what about this? So, see, if all the elements are same, then A transpose is also going to be equal as A only. How? So let's try to take transpose of A. We have our A as K, 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 K. What will be our A transpose? We will write our first row as the first column. So K, K, K. Second row as the second column. K, K, K again. And third row as the third column. So K, K, K again. So all the rows and columns are just K here. That means A is basically equal to A transpose only. So if A is equal to A transpose, so A plus A transpose can be written as A plus A again, which is just 2 times of A. Now, the question asks us to find the value of determinant of A plus A transpose, which is basically equal to determinant of 2 times of A, substituting the value of A plus A transpose as 2 times A. And here we know that if we take 2 out, so it will not just be 2, it is 2 to the power 3 because it is a 3 cross 3 matrix times determinant of A. And since the value of determinant of A is 0, it is going to be A times 0, which is equal to 0. So the determinant of A plus A transpose is also equal to 0. So option number 4 is correct. Option 5 says that determinant of A and A plus A transpose cannot be determined, and we have just determined its value. So it is incorrect. Now, moving on to the question 4 that says two rows are same in a 3 cross 3 real matrix, then the determinant of that matrix is 0. So let's analyze this option here. So we are saying let ith row and the jth row be same. Let ith row and jth row of a matrix be same. So what will happen in this case? So I can easily do this row operation that if I subtract the jth row from the ith row, what will happen to my ith row? It will basically become a 0 row. And I know that if there is a 0 row in my matrix, then the determinant of that particular matrix is going to be 0 as well, given the matrix is a square matrix. I can show this with the help of an example as well. So if I have my A as 1, 2, 3, 4, 5, 6, and some 4, 5, 6 again. So here, if uh, if I do to find the determinant of A, if I basically say uh, row 2 minus of row 3, that will result in this 1, 2, 3, 0, 0, 0, and then 4, 5, 6. And since there is a 0 row, the value of the determinant will become 0 as well. Why this happens? Because if I expand this determinant along the 0 row, so let's say a minus of 0 times of 2, 3, 5, 6, and then plus of 0 times of 1, 3, 4, 6, and then minus of 0 times of 1, 2, 4, 5. So since every small determinant is getting multiplied with 0, eventually it will become 0. So it's basically 0 plus 0 plus 0, and that will give me 0 only. So determinant of A is 0. So from here we can also get one more result, that if there is any 0 row in your matrix, then the determinant value of that particular matrix is also going to be 0. And it is not just true for the rows, it is also true for the columns as well. And we can use the same logic in the columns. We can assume any two columns of a matrix to be same, and then we can do the column operations. And if there is a 0 column, we can expand along that particular 0 column, and we'll get the value of determinant of that particular matrix as 0. Now, moving on to the option 3 that says uh, if one row is a non-zero multiple of another row in a 3 cross 3 matrix, then the determinant of that matrix is non-zero, and option 4 says that it is 0, but it talks about the column. So we'll just talk about the rows as of now, and we'll use the same result for columns also. So again, so here I am saying for option number 3, let ith row be a multiple of jth row such that r of I is some k times of r of j, whereas k is not equal to 0. So here I can do the column of row operation again, where I can just subtract k times of row j from my row I. And this property I have already seen, that if I add or subtract some constant type times another row from a particular row, then the value of determinant remains unchanged. So that means here I will again obtain a 0 row, since Ri is basically equal to k times of Rj, and the presence of 0 row indicate the value of determinant of A as 0. For example, if I want to find the determinant of this particular matrix, that is 1, 2, 3, and let's take 4, 5, 6, and here I have 2, 4, 6. So if I do this operation here, that row 3 minus 2 times of row 1. So what I will get? I will get 1, 2, 3, 4, 5, 6. And in row 3, I'm subtracting 2 times of row 1. That is 2 minus 2 times of 1. That is 0. 4 minus 2 times of 2. That is 0 again. And 6 minus 2 times of 3. That is 0 again. So again, I am obtaining as a 0 row in this particular matrix. So the determinant of this matrix is going to be 0. So if there exists a row which is some constant times another row, and that constant is not 0, then it means the determinant of that particular matrix is going to be 0, given that that particular matrix is a square matrix. And we can use the same result for column as well. Just in place of writing rows over here or doing the row operation over here, we can do the elementary column operations. So this was all about the option question number 4, where it says non-zero, so this option is incorrect, whereas this says the determinant of the matrix is 0, so this option is correct. Moving on to the question number 5, which says that just evaluate this particular determinant. So we are given a matrix and we have to find the determinant of. So let's expand it along row 1 maybe. So we are expanding along row 1. So what will happen? We have determinant of A as 1 times this 3 cross 3 matrix. So 1, 0, 1 and then 0, 0, 1 and then 0, 0, 1. Then it is 0, so we can ignore it. So plus, minus, plus, minus. And then plus 1 times of. So to obtain the matrix, I just will eliminate this row and this column. So I'm getting 0, 1, 1, 1, 0, 1, and then 0, 0, 1. So yeah, it is 0, 0, 1, 1, 0, 1, and 0, 1, 1. So here, in this question, now let's see what will happen to this particular value of the determinant. So I can again expand this determinant over here. So this time I'm going to expand along row 3. Why row 3? Because there are already two zeros over here. So I will just have to check for this one, plus, minus, plus. It is 1 into some 1 times of this small determinant, which is 1, 0, 0, 0. And now it is plus 1 times of. So now we have the options. Here also we will expand along row 3, plus, minus, plus. So it is 0, it is 0. Let's neglect these values and now just focus on this one. So it is 1 times of this determinant 0, 1, 1, 0. Okay. So this is 1 times of 1 times of 1 minus 1 times 0 is 0, minus 0 times 0 is 0. So it's basically 0, plus 1 times of 1 times of the value of this determinant is 0 minus 1, that is minus 1. So it is 0 minus 1, that is minus 1. So the value of this determinant of A is minus 1. So our answer is minus 1. So this is all about this video where we discuss the first 5 questions of activity 1.5. So bye, we'll see you in the next video.